Hey students, in this video I'm going to go over the notes of Algebra 1 review, solving 2 by 2 systems by substitution. Okay, so just to review first what solving 2 by 2 systems is in Algebra 1. We are used to seeing equations that look like mx plus b, and we know we could graph that in the calculator and it'll give us two lines that are either going to intersect at one point, or we're going to have lines that are going to be parallel. And these two lines are not intersecting at all in any point. Or we have the scenario of two lines that when you graph them, they are exactly the same line. So those are the three things that could happen when you graph a system of 2 by 2 equations. So here you have that summarized. When you have one solution, it's that point of intersection. When you have no solution, it's when you have two lines that are not touching. And when you have infinitely many solutions, that's when you have two graphs overlapping each other. So what we're doing in this notes are finding that one solution right here, usually written as an x comma y, an ordered pair, but we're doing it algebraically. So solving equation skills are very, very useful here. Good thing we have been reviewing them for the past two school days. So here is the first example. We're going to follow these steps. It says to set one equation equal to a chosen variable. So you are going to look and find, based on what you see, is it easier to rewrite an equation into x equals or into y equals? You have that choice. So based on what we see on the top, that's in standard form. That is going to take several steps to rewrite as x equals or y equals. But the bottom equation is easy. You could just isolate the x by getting rid of the 3. So we're going to choose this one, and we're going to write it down and solve for x. So we're going to divide by 3, and x equals 2. So that means that whenever we see the x, we could replace a 2 in there. The next thing you want to do is substitute the equation from step 1 into the other given equation and solve the resulting equation, which means that since we use this one to isolate for x, we are going to replace or substitute this x value or expression into the other. So what I'm going to do is I'm going to write that other equation, and I'll write it as 3x plus 7y equals 14. And once again, this x will be replaced with what we have here. So we're going to write it as 3 times 2 plus 7y equals 14. So that is the second step. We are substituting this value or expression into the other equation for the letter that we found. So then now we have to solve for this resulting equation, which means now we have to solve for the letter y. So we're going to multiply 3 times 2, which is 6. Then we have to get rid of the 6, so we can end up with y equals. So minus 6. And then you have 7y equals 8. And now we need to get rid of the 7 in front of the y by dividing by 7. So we get the fraction 8 divided by 7, and that is okay. That is the y value that we get for this equation. So these two x and y values will create that solution point. This is where two lines intersect at one point, and that one point of intersection is a 2, 8, 7. That is your solution. Okay, we're going to try that again with the next two examples. We have these two equations, this system, and looking at that, it looks like the top has a y equals already, and that means that we can replace the other y with this expression right here. It's already isolated for y, so we just substitute that in for y on this equation. So let's do that. 5x minus 4y equals -3. And if we replace this y with this expression, it's going to look like 5x minus 4. And we're going to substitute by putting parentheses and the whole expression, -3x plus 5, and then equals -3. So we're just substituting the expression that y equals into the other equation for y. Now we solve. So practice distributing that -4 times -3, -4 times 5. This 5x was not going to be distributed, so we just write 5x. -4 times -3 is -12. -12x, because that's a 3x. -4 times 5 is -20, and then -3. So now we keep solving until we get what x equals. So these two are like terms. We combine those. 5 minus 12 is -7x. And then -20 plus 20. So we can move it to the other side. Actually, this is negative. Well, this is positive. -4 times -3 is positive. I'm so sorry. I overlooked that. So -4 times -3 is positive 12. 5 plus 12 is 17. Positive 17x. And then over here, when we move the 20 to the other side, we get positive 17 as well. So to solve, we need to divide by 17. So x equals 1. So our solution is so far with the value of 1 for the x, and now we need to find the y value. To find the y value, we're going to use the variable found, and we're going to substitute it into an equation and solve for the other variables. So just like we did here, we are going to now substitute this 1 into the other equation. So I'm going to copy down the first equation. I'll just draw a little line here to separate. And we are going to substitute the answer we got here for x. So we're going to have y equals -3, parentheses 1 plus 5. And then we're going to have y equals -3 times 1, which is -3 plus 5. And then -3 plus 5 is positive 2. So your y value is a 2. We have a system of equations that intersects at the point 1, 2. All right, the next one, last example together in this video is the following. Looking at these two, the top or the bottom, we notice that the bottom is more steps to get into x equals or y equals versus the top one. The top one already has a y by itself, so we just need to move the 7 to the other side. So let's do that. We're going to rewrite this as y equals. That means we need to move the 7 by subtracting 7 on both sides. Cancels, and you end up with 5x minus 7. So this expression of 5x minus 7 will substitute the y value in the other equation. So we're going to now go ahead and write this other equation. So -3x minus 2y equals -12. And then we're going to substitute it into the y, this whole expression of 5x minus 7. So -3x minus 2 times 5x minus 7 equals -12. So we're going to distribute, because there's parentheses, we're going to distribute this in there. -2 times these two. So -3x just comes down. -2 times 5 is -10x. -2 times -7 is positive 14 equals -12. And we're going to keep solving this until we get x equals. So next, combine like terms, which is 3x minus 10x. So that's -13x Then we're going to write down what we have left. And then we want to keep the x, we need to get rid of the 14 and move it to the other side. So negative 13x equals negative 26. So the last thing is for us to divide by negative 13. And then we're going to get x equals 2. So that x value of 2 is part of the solution so far. Now we need to find the y. So I always recommend to go back to the original equations and substitute that into the original equations. So I'm going to now use the top equation, y plus 7. I'm sorry, yes, y plus 7 equals 5x. And we're going to substitute the 2 that we found in for x right here. So we're going to put y plus 7 equals 5 times 2. And we solve. So y plus 7 equals 10. And then we subtract 7. And y equals 3. So the solution has a 3 as a y value. All right. I hope these 3 examples help you understand how to solve a system of equations algebraically.